All right, so we're back for part 3. Here we see our first sample script. I'm going to be posting this online along with these notes so that you can open it up and make sure that you can run each line separately. We've already pretty much done that, but run these other expressions such as long variable name, really long variable name, and use these other functions such as factorial. And so make sure that you can do that. This will become part of the in-class work for this week, though nothing to turn in. Just make sure you run it, and if you have any problems, let me know. Documentation in R. Generally, R functions are all documented. Even some objects are documented in R, and it gives the following components to the documentation file. We have a general description of the file, of the function, a description of their arguments and default settings, details about the computational aspects of the function, typically, any caveats it needs to make, a list of the values. So there's a whole section called values, and it's what is returned. What do you get from that function? References, usually these are academic references for the actual development of the procedure or method. And some examples. Sometimes when I'm first learning, I read the description, look at the arguments and default settings, and then go straight to an example just to make sure I can understand it first. Documentation is sometimes good and sometimes not so good. It really depends on the author of the package. And so you see a lot of variation. It's not like SAS where it's all written kind of by the same team of people. It's written by individuals typically. It's not intended to use for instruction, but instead just a reference. There are a lot of educational resources for R that I will make available as we get going within this section, but our main is our textbook in this course. There are a lot of listservs in R, and as well as websites that help you with R problems that you have. If you ever need help about a function, you can type question mark and the function name. So for example, if it's the function mean, you could do question mark mean and enter it within your console or editor window, and the help file will pop up. Another way to do it is just to do help with the function name within parentheses. When you're not sure about what the function's name is, you can use the keywords approach. When it's a new function for me, I often have to use this approach. So maybe I know it has to do with the GLM and is some function of the GLM, then I might do question mark GLM, and it will give me every function that has something to do with the GLM. And a list of those functions will look like this typically. It'll give the package first and then the function name, and that is really important to pay attention to because sometimes there are multiple functions that have the same name and they're within different packages. So you need to actually know which package your function belongs to. You can also run examples that are loaded for your package. And if you have, say, the function mean, you could run example mean and then see some system examples for that function. That helps when you're learning sometimes. You can do the same thing with demo. This is even more helpful, I think. All right, so some examples. Question mark LM will pull up the linear model. LM stands for linear model. Help search regression. Well, if you don't know what the regression model is, it happens to be LM. This will help you figure that out. Okay, and then to execute an example for the linear model function, you could just do example LM. So if you want to get an overview of your function and everything that's in there, you can just do help package equal package name. I'm sorry, I should have said package rather than function. Sometimes, not all the time, but sometimes there are vignettes, and this will give you additional documentation, lots of examples, lots of explanation. When they are available and I'm having trouble with the package, I find these really helpful. I don't know like the proportion of times that they're available. It seems kind of haphazard right now. So suppose we're interested in doing something like a flowchart. This is something I didn't know at one point how to do in R. We can use, there's a package called Diagram that will help us do that. So first you have to install and download that package, and you can do that by install.packages. Remember, you put Diagram within quotation marks. Then we need to load it using library or require. Then we can take a look at all of the functions that are within our package Diagram. Then we can view the vignette. And then we can look at a specific function, plot mat, that's within the Diagram package. So let's go ahead and run through all of this and make sure you can install the package, attach the package, find the help file and all the functions, look at the vignette, and then look at documentation for a particular function, such as plot mat. Here I am within the R programming environment. I have my editor window open, and I'm just going to run through each of these. I started a new fresh session just so it would look somewhat like what you may be seeing. It's going to run through install this. I haven't run this on this installation, so this will be authentic to what you see. Then we run this. It's giving you some warning messages because this was built under a previous version of R. That's okay. We can take a look at all of the functions available. Notice here they all are. You can click on any one of these and get more information such as plot math there, which gives you this network type graph. Then we can look at the vignette. I'm getting an error when I run that. I might have to check out what's going on. Well, if that happens to you ever, you can usually just get it by Googling it. There we go. So for some reason, my access was denied, but here we go. Here I have the vignette, and you can see this gives you a lot more information about what you can do using this package. Very nice. I love these models here. This is very useful for some of the graph theory stuff I work on. And finally, if I wanted to look up information about the plot mat function, I just do this, and there I get all the information. So remember, we talked about how it's the description. It visualizes a transition matrix as the number of labeled boxes connected by labeled arrows, so kind of like a directed graph. Then we have all the information about all of the possible arguments within the plot mat function and what their defaults are. A lot of arguments there. If we go down, we see details about the calculations and what's done. And then finally, we see value. What do we get out? We can get a list containing arrow information, a matrix containing the element positions, the radiuses of the transitions between the vectors, and then the rectangular coordinates. All right, so let's continue. All right, so we can change our work directory anytime we want. We simply use the command set wd, and you put in your file path. This is really useful to help us point R to the place that we want to save any of our R files, or if we want to save any of our R tables. You can also click and point, change your directory, and just pick a location on your drive. That's fine. I like to programmatically do it, and I just always copy and paste that set wd function at the top of my programs. The workspace is what you create during a session, and when you close R, it's going to ask you, should I save this workplace image? If you say yes, then the next time you open R from the same working directory, everything you've done at that session is going to be restored. You can also use the save image command to do that. I don't always do it. In fact, I rarely do. I usually want to start a new session the next time I open R. If it's taken a lot of work to get where I was and I want to start back up and only I'm quitting because I need to, then I will save my workspace image. So you can manage your workspace by getting a sense of what variables you've created in the ls command. gives you that. You can search your workspace. You can see what libraries you've installed during your workspace by just doing library open closed. You can remove objects, and you can remove all objects with this command. So here you can just remove specific objects versus all. So other things that we can do is we can change the options. I often do this. I'm all the time changing the number of significant digits saved. The default is 8. However, sometimes we want to have better precision. Sometimes we want to have less if we are rounding off for some particular region. So, I'm sorry, I said 8, and it's actually 7. So I'm all the time changing mine. The maximum you can get reasonably without using some other tricks is 22. And if you're going to be doing computations with very, very large numbers or very, very small numbers, I recommend that you just set your digits to 22 until it comes time to print out your results, and then set them back to something more reasonable. All right, so that's it for the introduction, getting started in R, and we'll pick up with R next week after our the rest of this unit.